All right, so I think now we have quite a bit of a locomotion system. Like we have sort of cardinal based animations and walk, also crouch and sprint as well. Right. So as I said earlier, I think we can make some fixes for the existing locomotion system to make it bit more smoother in their transitions, right? So let's do that today. Okay, so the first thing I can do is that uh, sprint issue fix. Like if I show it to you again, so if I quickly make shift or press shift whenever I start the sprint, it seems like speed is increasing, but animation is takes some time to be played, right? um, so we can fix that issue real quick because I think it happens because of this function. So set anim data, and inside this sprint, so since we doesn't have a sprint start animation in our data table, so if I show our data table for you real quick, so we currently doesn't have a start sprint animation. So therefore what it basically do is it will replace it using the start cardinal animation instead of the sprint start animation, right? But I think since we have the sprint cycle animation, we can say if we already have the sprint cycle animation, then replace it using that animation instead of going to these cardinal directions, right? So let's add another is valid like this, and I'll move these three to here as well, right? So if we have a valid sprint cycle animation, we can plug it to here, right? And if it doesn't have a sprint cycle animation, then we are replacing it using the start cardinal direction animation. And similarly, I think we can do the same thing for the stop state as well. So I'll plug it here. Sprint stop is not valid. It is replacing using this is sprint cycle if it is valid, and if not, it's replacing using stop cardinal direction animation. Okay, now compile, save, and play test again. Right, now it's working properly. Okay, great. Okay, that sprint issue is fixed now. Now we can do some improvements for the animation graph transitions as well, right? Yeah, so let's go through each transition one by one. So this is the first transition we have, and we have this acceleration check and stop and validity check. So this would be fine. And then let's go to this one, and we are checking sorry, we are checking basically whether we have valid stop animation to be played, and start anim is not playing, and we jump to the stop. Plus I think we can add a property access here, We can get the movement component, and let's say be orient rotation movement, and if this one is true also we can do a transition. Right, so this is job to stop. So let's try that out. Yeah, that rule is sort of failing. Yeah, maybe we can add another transition rule that applies the opposite of it, which is the priority order of 2. Not this one, actually, this one. This one has the implementation already. And for this one, let's make it as priority order 2. And I'll copy the existing logics and go to here, paste it there. Let's keep this 2 as usual, but this one not boolean. Right, so let's play. Yep, that's for the strafe mode, and let's check the forward facing. Okay, seems nice. Okay, that's the second transition fix that I can see. And then what? Then let's go to this priority order 1 transition, and we can do a stop to idle transition if the anim state is changed or crouch state has been changed. Right, so this is stop to idle, and let's go to the crouch. Yeah, works properly. And then you have the priority order 2, and this is just automatic rule based transition, I believe. Yeah, yeah, automatic. It should be pointed as automatic rule based transition. Yeah. Okay, then this cycle is done, so let's go to this cycle. Let's check this transition again. So we are checking whether we have a valid start anim plus whether the start anim is playing, and if both true we make a transition. That's fine. And let's check the countermeasure. Checking whether we don't have a start anim and the start anim is playing, and we make another transition. That's also fine. And let's check this priority order 1. Here actually multiple different stuff can be happen. Yeah, do we have a reference for the rotation mode change? No, right? So I think maybe we can add a state for the rotation mode change as well. So let's go to the locomotion event graph, and yeah, I think it doesn't even have a one for the rotation mode change, right? Event dispatcher. So let's add it real quick, because later on actually we may get use of it. Okay, so let's add a new event dispatcher called event on set rotation mode. Right, and this is type of rotation mode enumeration. The parameter name is rotation. Okay. Yeah. So let me quickly see my documentation real quick. Yeah, this is the set rotation mode function. Set movement config, and let's call the thing here. And as the rotation mode, you can pass this existing rotation mode. Okay, great. Now let's jump back to the ABP locomotion. Let's go to the main graph initialization, and let's bind another event for the rotation mode change. Right, so let's create an event called what? Event event on set rotation mode. As usual, I'll move it to the locomotion event graph. And now that reference has been broken, so let's fix it like this. Compile. And here, do we have a locomotion state machine data for this? Locomotion system data, maybe locomotion system. Maybe it doesn't have such thing. So let's promote it to a variable called ls rotation mode. I push to the locomotion system category. And as usual, like we did in here, before setting this one, let's first check whether we have a difference in between a current state and the new state. And if we have, then we set it. Right? And once we set this, we can mark it as rotation mode changed. I'll push it to the character state data category. We can mark it as rotation mode changed. And as usual, I think we can set animation data here, right? Or maybe we can do setting first and transition later. And let's add a small delay, and let's reset the value. Okay, now that rotation mode change state has been captured. Now let's go back to the event graph locomotion, and I think we were at here. Okay, right. So now we can add multiple different transition. So start to cycle can happen if an inset changed or rotation mode is changed or crouch state changed, or even movement state changed. Okay. So these are the possible state that I can think of to make a transition from start to cycle. Right. For example, let's say if we are in here. Yeah. I think there is another bug as well, like if I try to sprint when I'm at crouch state, it will have this issue. Yeah, we have another issue to be fixed, but let's check that start to cycle thing. Yeah, how it works properly. Great. And then what? Then maybe we can, yeah, we have added this automatic rule based transition as well. Great. And then let's look at the pivot stuff. So the first transition is anim set change. That's fine. And and maybe we can add another transition. Like this. Like this, yeah. And let's make it as priority order 2. And let's say movement state is changed, then we make it do a transition. Plus we have a helper function to check whether we are moving perpendicular to the initial point. No, right? Yeah, maybe we can add another helper function as well called is moving perpendicular to initial point, because if we are moving perpendicular to the initial point, then we don't need to necessarily play pivot animation again and again, right? Instead of that, we can simply jump back to the cycle state and play it back, right? Because the pivotal change should happen only like 180-degree transition happens instantaneous, right? Not like a 19-degree transition, which is a perpendicular movement. But let's first check whether we are having a perpendicular movement or not. So I'll make up your function, and we can check whether we have pivotal perpendicular transition. So do we have pivot initial direction? No, right? So first, I think we have to capture the initial pivot direction. So let me quickly look at my documentation. So let's go to the anim graph, locomotion, pivot, and here one become relevant. Let's add a state node function. Create binding. And I'll name this as setup pivot state, and this is a snared function. And here, since we have the local velocity direction, I can promote it to the another variable called pivot initial direction. right? And let's move it to the locomotion state machine data. Right, now since we have that variable, you can go to this is moving perpendicular to initial point function, and let's use that pivot initial cardinal direction and check whether it's forward or backward. Or alongside the local velocity direction is forward or backward. And if it is not, and let's take a end here. And similarly, so here we are basically checking whether pivot initial direction is forward or local velocity direction is not forward, right? And vice versa for the backward. And similarly, we can do similar thing for the left and right. This should be left, should be right, and left and right. And let's take O. So if one of these transitions satisfied, then we can return node like this. Okay, so this one is basically doing in overall context, what is tried to achieve is, if we are if we were previously moving to the forward direction and now we are trying to move to the left direction, then we are moving in perpendicular to the initial point, right? So it will return true. But let's say if our previous direction is forward and our current target direction is backward, then it's not a perpendicular movement, therefore it will return false. So vice versa logic will be applied for the left and right as well, right? So this is what this helper function basically does. And I'll move it to the helper functions, and we can go back to the anim graph, locomotion, and this second priority order transition, right? And there what we can do, we can get this perpendicular initial point, and if one of these conditions satisfies, we can make a transition, right? Okay, so let's yeah, let's make it as thread safe, compile, and let's make a pivotal transition real quick. Yeah, the pivotal doesn't appearing properly for the strafing forward facing, so let's switch to the strafing mode. Yep, that pivot is happen. But here you can see, if I make a pivotal transition, if I make a perpendicular transition from left to forward, it doesn't show me that pivotal transition. But if I try to move from backward to forward, then yes, that pivotal animation is showing, right? So it works for the 180-degree transition, but not for 19-degree transition, which is what we needed. Okay, then what we can do is, let's check the other transitions as well. So this one, yeah, checking whether we have valid pivot anim and dot product for the velocity and acceleration, and we can check that orient rotation stuffs as well. So let's get the movement component and B orient rotation to movement, and if this one is false, you can make a transition as well. This pivot sources to pivot. So let's see. Yep, so it's come proper. And then what? And then we have the countermeasure, which is here. I check in this one, which is fine. This one and this one. Similarly, we can get the property axis again, orient rotation to movement, and this one as well. So this stuff will comes in handy when we make a transition from strafing mode to forward facing mode. So you will see those stuff in action later on. But for the cleanup, I think it's nice to have this stuff at the locomotion state machine, right? So it has been done, and let's check this one. Validity, okay, and finally this one. I check in this one and this one. Okay, so I think those are the transition updates that I require to be done. Plus we have resolved that sprint issue at the start state, and yeah, so I think those are the potential bugs that I need to fix and some of the improvements that I need to address. But here, as you can see, some of the foot sliding is involved. Like you can see, when we are sprinting for the orthogonal direction, like it's not working properly, right? And even if I try to make like, let's say, quick stress transition for the, you know, for a different direction rather than the cardinal direction, it seems like we are sliding through the ground, right? So this stuff can be resolved using warping, and specifically the orientation warping, by rotating the root bone of our character for that specific target direction, right? And let's look at those stuff in future episode, and thank you and see you there.